So this video is going to help with the Lab 2, the graphing part of the lab. So if you watch the other video, this first part where we are getting the length, width, and height of a wooden block, you will get those dimensions from that video. What we're going to focus on, when you turn this around, so we're on page 16 here, you'll notice it's a graphing exercise. So you are given a table with data, and you're going to use that data, graph that data, and then use your graph to predict results. So you want to start by setting up your graph paper with an X and a Y axis, so the X axis along the horizontal and the Y along the vertical. Notice step A says you want the mass along the Y and the volume, so this column, along the X. So when you are doing a graph, you want to do your XY axes and then you want to label them. So for instance, if you look at my graph that I've already started, I have labeled the x-axis with volume in centimeters cubed, which is what that data is given to us in. And then I've also labeled the y-axis with mass in parentheses grams, because those are the units that the mass is given to us in. So the next step then is to number your x and y axes. So you need to figure out a good increment that would be useful. So when you're trying to figure out an increment, it's good to look at your range of data. So for the mass of the sample, we are going from 2.25 up to 11.28. So my range of data is basically from 0 up to 12. Okay, so for the mass, my range is going to be 12 grams. Then, in order to figure out your increments, what you want to do is figure out how many boxes you want to use. And you want to use more of the graph rather than less. So the larger your graph is, the easier it is going to be able for you to read, so that when you're making your predictions, it's just going to be a lot nicer. So say I want to use 10 boxes. So however many boxes I want to use, I'm going to divide my data range by the number of boxes I want to use. So if my data range is 12 and I want to use 10 boxes, I'm going to do 12 divided by 10. And what that does, when I divide that out, I get 1.2. So this gives me an idea for what each box should be worth. Now, going by 1.2 for each box is going to be really difficult, because I don't want to go to my graph and have each box worth 1.2, because that's just hard. 1.2, so the next is 2.4, the next would be 3.6. Like, that's just an awkward number to count by. So instead, round it. Let's say each box is going to be worth 1 gram instead. So that's what I did along the y-axis here. So I picked my range. Each increment is going to be worth 1 gram. And instead of going every 1 box, I went every 2, just to make it even larger, to use more of the graph. So 2 boxes worth 1. The next 2 boxes also worth 1, so now I'm at 2 grams. Next 2 boxes worth 1 gram total, I'm at the 3. 4, 5, so on and so forth. Notice I went all the way up to 12 because my data goes up to 11.28. So I need to make sure I go large enough to get to all my data on the graph. For the y-axis, for the x-axis, the volume sample, I'm going to do the same thing. So I take my total range, which is 1.67, and I want to use the same number of boxes I used for my mass range. So say I use 10. Okay, what that's going to give me is 0.167. This is going to be centimeters cubed. Well, I definitely don't want to count by that. So this time instead I'm going to round up, because notice there's a 6 next to the 1, so it's just better to round up. So instead my increments are going to be 0.2. So if you look at my x-axis, when I go back to the graph, my x-axis goes by 0.2. So every 2 boxes worth 0.2. So 0.2, then 2 more boxes, 0.4. 2 more boxes, 0.6, so on and so forth. The most important thing is that each of these marks are worth the same amount. So for instance, I don't want this increment here to be worth 0.2 and then this increment to be worth 0.7. Okay, they need to be worth the same for the graph to work. All right, so now that we have the graph numbers labeled, let's plot the points. So when you're looking at these data points, remember the mass is the y-axis and the volume is the x-axis. So you have 5 data points that you are going to plot. This first data point is going to be 0.333 on the x-axis. So I'm going to go on the x-axis. My 0.3 would be right here, between the 0.2 and 0.4. But it's 0.33, so I don't want to be exactly on that line. I want to be a little further over. So this does include some estimation. And you'll want to use pencil when you initially do your graph, just in case you make a mistake, you can erase it. I'm just using pen so you can see it better. So hopefully I don't make a mistake. Okay, so I'm at 0.33 on the x-axis. Then I'm going to look over to the corresponding y value, and it's at 2.25. So I'm going to go all the way up till I get to 2.25 on the y. So here's 2. This next box would be 2.5. So I want to be right in between those two. So there's going to be my first data point. I'm going to do my next data point. It is 0.545 on the x-axis. So 0.5 would be here, and I want to be at 4.5, so in between these two. Then I'm going to follow it over. I'm going to go all the way up to 3.68 on the y. So here's 3. This would be 3.5. And I want to go to 3.68, so I'm almost at 3.7, so it'll be somewhere in here. Okay. Next data point, 0.859, so I'm at the 8. This would be 0.9 here, so I want to be somewhere in between that. I want to go up to 5.8. So the 6 is right here. 5.5 is right here, so I want to be at 5.8. Next data point, 1.38. So my 1.3 is here. So it's almost at 1.4, so it's almost at this line, and I'm going to follow it up to the 9.3. So here's my 9 and my 1.4. Okay, and I want to be at 9.35. This is 9.5 going across, so 9.3, probably be somewhere around there. All right, last point, 1.67. So this is 1.7, so I want to be a little bit to the left of that. And then 11.28. So let's follow this line up. Here's the 11 right there, and I want to be at 11.28. So this is 11.5 here, so I want to be lower. Okay, now your graphing should go better because you're not trying to work over a camera. So your points might be a little bit more accurate than mine. When you are done graphing that, your next step is to draw your best fit straight line, and you're going to start at the 0, 0 mark. It says use a pencil so that you can erase it if drawn incorrectly. So once again, I'm using a pen. I do not want you to use a pen. So I'm starting at the 0, 0. That's the origin. Oops, sorry, that's the origin right here. 0 on the x and 0 on the y. And what I'm going to do is I'm going to try to line this up as best I can. Now I might not go directly through all of my points, and that's okay. Go through as many as you can and keeping the same amount above and below the line. Okay, so here's what I'm going to call my best fit line. And notice I didn't go through all the points. This one here is a little off, and that could have been my error, or it could be an error in the data, because not all data is perfect. So Once you have your best fit straight line, you want to find the following. So I just wanted to show a few examples of this. So it is asking, for instance, what is the volume of a 10-gram sample of this material? Because notice in the data, there isn't a 10-gram sample, but we can use our graph to figure that out. So to figure that out, you're going to go over to your graph, and we're going to find where 10 grams is. So remember, mass is on the y-axis, So we're going to go up to the 10-gram mark. So this line here. And to figure out the corresponding volume, we're just going to follow that 10 grams over until we hit the line. And I'm going to hit the line right here. So wherever I hit that line, I want to follow it down to see my corresponding volume. And it's going to hit approximately right here. So not quite on this dashed line, but close. So it's between 1.4 and 1.6. It's not quite at 1.5, but it's very close. So I would maybe put 1.48, for instance. Okay, and you're going to use your graph. So you might get 1.5 exactly. You might get a little on the other side of the 1.5. So use your graph to predict these amounts. All right, and you're going to do that for each sample given. So they might ask you, for instance, the third one down is asking the mass, corresponding mass, if you had a 0.750 centimeter cubed sample. So 0.75, so 0.7 would be here, 0.8 is here, so 0.75 would be right in between. I follow that up until I hit the line, and I hit it right here. Then I'm going to follow that over, and it's going to be a little above the 5. It's not quite at 5.5, so I would say 5.20 grams would be my prediction from my graph. So you will use your graph to do those predictions. So using these following steps, you are going to do another graph with this helium data on pressure and volume. So you will do another graph. You're going to draw your best fit line between the points, but on this graph you are not going to do a straight line. It's going to be a curved line. It's an exponential graph. So draw your curved line, and from your curved line you are going to answer the same types of questions that we just looked at for the first graph. You'll follow your curved line over and answer the following. Okay, so that is my tutorial on finishing the graphing portion of your lab. Let me know if you have any questions. I can always supplement this as well. Thank you.